Thank you, Diane. Yeah, welcome back, everyone. So if the fireside chat was about our national strategies or why it matters, now this panel tackles how our three neighbors, three playbooks, shared ocean of opportunity. So here's the format. So we're gonna have three speakers from our ASEAN neighbors. So for the first speaker, we're glad to have Mr. Manoj Harjani. He is a research fellow and coordinator of the Military Transformations Program at the Rajaratnam School of International Studies. His research focuses on regulation and governance, critical and emerging technologies. Prior to joining RSIS, Manoj worked in Singapore's civil service with stints at the Ministry of Trade and Industry, Prime Ministers of Office Strategy Group, and Public Service Division. So, Manoj, you may now start your talk. Thank you.
Hi everyone, thanks. I hope you can see my screen. So I'll just give you a quick overview of what I'd like to talk about first. So I'll spend a little bit of time talking about Singapore's quantum journey, then get into the strategy itself, and talk about some challenges and opportunities. And lastly, we'll try to take a quick look ahead at what's happening with the strategy itself. So this talk that I'm sharing with you today, it's based on a piece that I've written recently. And if you'd like to, you can scan the QR code on the screen to read it at your leisure. So just a caveat, this little capsule history I'm going to give you of Singapore's quantum journey does almost no justice to the incredible amount of work that researchers, officials, enthusiasts have been doing in Singapore for more than 20 years. But unfortunately, with time being limited, these are the highlights that I wanted to mention. So the journey sort of starts officially in the early 2000s when a initial research group was set up on quantum information science. Fast forward a few years after that, in 2007, the first Research Center of Excellence, or CQT, the Center for Quantum Technologies, was set up with a grant to run for 10 years. Fast forward many years after that, many achievements later, CQT building a world-class research ecosystem in Singapore. In 2022, Singapore's government set up a national quantum office. And last year, and this is the highlight I'm going to be talking about, Singapore launched its national quantum strategy. And this is backed by about $300 million under what's called the Research, Innovation and Enterprise 2025 plan. So this is a plan that guides public sector R&D in Singapore. Now, the National Quantum Strategy responsibility to implement that lies with Singapore's National Quantum Office. And Singapore's NQO also has oversight for the quantum engineering program. Now, this aims to kind of work on translational research to try and scale up and have commercially viable applications and solutions. It's been around for about 7 years now. And as you can see, the funding has been topped up over time. Now, through the quantum engineering program, the NQO also supports various other national initiatives. So as you can see on the screen, a national quantum safe network to trial quantum safe communication technologies, a national quantum computing hub to build domestic capacity in quantum computing, and a national quantum federated foundry. So this looks at design and fabrication capacity for quantum devices. Now, let's move on to talk about the national quantum strategy itself. So, the vision is actually quite straightforward: strengthen Singapore's position as a leading hub for developing and deploying quantum technologies. And this is a desired outcome that has been constant across Singapore science and tech policies for many decades. Um, Now, within the NQS, there are actually four strategic thrusts: scientific excellence, engineering capabilities, innovation and enterprise partnerships, and talent. And I'll be going through each of these in turn. Okay, so here you've got an overview of sort of the main thrusts of the National Quantum Strategy. As I mentioned, I'll be covering each of these in turn. So when it comes to scientific excellence, the main initiative under the strategy is to support the elevation of CQT into a national flagship research center. Now that happened earlier this year. And what that means is that CQT is now overseeing research nodes across three of the major universities in Singapore: NUS, National University of Singapore; NTU, Nanyang Technological University; and SUTD, Singapore University of Technology and Design. And there's also another research node in the Agency for Science, Technology and Research, which is Singapore's national R&D organization. It's a public sector agency. And as you can see in the little diagram on the right-hand side of the slide, the idea is that there will be other universities participating down the line. But for now, this is the system that CQT manages. Let's move on to engineering capabilities. And this, I think, is actually a very key pillar of the strategy, because the quantum engineering program, which, as I mentioned, has been around since 2018 and has received, additional funding some years ago, it's being enhanced with two additional national programs: the National Quantum Sensor Program and the National Quantum Processor Initiative. So for NQSP, that was launched last year in August, and it's got a few focus areas that are kind of very closely related to possibilities for commercial applications. So in PNT, in biomedical sensing and imaging, and also in remote sensing. And for NQPI, which was also launched last year, the idea here is that it will support the National Quantum Computing Hub by strengthening domestic capabilities for designing and manufacturing processors for quantum computers. So it's building out that domestic supply chain for quantum computing. Moving on to innovation and enterprise partnerships. So this is a feature of a lot of Singapore science and technology policies. There's an emphasis on collaboration with industry. There's a strong desire to encourage spin-offs and startups. And if you see on the box on the right, CQT has been very successful in recent years in having spin-offs. So the example that I think is often mentioned is Spectral. It was spun off in 2019, and it looks at solutions for satellite-based quantum communication systems. And there are only a handful of startups in Singapore now, but this is not going to be static, and it's likely that you'll see growth and further spin-offs occurring. And this is one pillar behind the NQS in Singapore. And one of the more recent examples is that the National Quantum Computing Hub, it's trying to partner industry to develop use cases in finance, drug discovery, logistics. These are all aligned with sectors in Singapore's economy that are also priority areas as part of overall economic strategy. And there are sectors where Singapore has developed advantages over some time. Okay, and now we're at the final pillar of the National Quantum Strategy, which is talent. Very crucial for a country like Singapore, which has a small population, which is reliant on global talent. And so this is why there's a national scholarship scheme as part of the National Quantum Strategy. The idea is to grow a pipeline: 100 PhDs, 100 master's level graduates over the next 5 years or so. So far, you've got about 14 PhD students that have come into CQT since earlier this year. And You've got master students that are going to be coming in later this year. And if you see the chart on the right, you can see that students, postgraduate students, make up a very big chunk of the CQT community. So they're very vital for sustaining the quantum ecosystem in Singapore. And this is why the National Scholarship Scheme is a priority area under the National Quantum Strategy. Now, that's it for unpacking the quantum strategy. Let me get into the challenges. Now, I mean, this depending on your perspective, I hope it's taken in the right spirit. But uh, the sense that I have is that currently the NQS is lacking a translation of its vision into milestones. Um, I think especially it's difficult to understand what a leading hub looks like in practical terms, with so much competition and hype and changes happening in the quantum ecosystem. How do you assess the returns on the 300 million that's backing the NQS? So I think that's an important question that needs to be addressed. The other thing is this idea that currently there aren't any big measurable targets, but you see this in other countries' quantum strategies. So, for example, the UK has had its national quantum strategy with a number of quantitative targets. But then, does this give you the challenge of having tunnel vision? Uh, Numerical targets can be superficial. They might not actually give you progress, even if you achieve them. And Japan's tried to address this challenge by doing ongoing studies of how the quantum ecosystem has changed since its strategy was launched, and then trying to implement these course corrections while maintaining the continuity of its overall strategy. But I still feel that metrics matter because they drive behavior. They set kind of a North Star for people in the ecosystem. And so I think Australia's approach might be worth taking a look at. You've got no specifically defined targets in terms of, numeric terms or whatever, but there's a sense in the strategy that you've got particular things that will be measured. You've got indicators of success, and then these indicators of success are linked to the various action points outlined in that strategy. So that's maybe one approach around having very narrow numeric targets. The other area that's a big challenge for the NQS is that it seems like its talent pillar, which is it's laudable, the effort to have a national scholarship scheme, but it's quite dependent on PhD and master students. And this is something that I think looking to the US might be a good opportunity. So you've got the need to create alternate pathways to enter the quantum industry because at some point it's going to grow beyond the ability of PhD and master students to fill all of the roles. And I think what the US is doing in terms of its workforce development is something that I think could be a useful lesson. And lastly, in terms of challenges, I think the social and ethical implications of quantum technologies have yet to be addressed directly in the national strategy. And here's where I see the example of the Netherlands being very helpful. They've got a Center for Quantum and Society, and they've been looking at ethical and legal frameworks in support of what we can call quantum for good. So this is all not doom and gloom. You've got a lot of opportunities ahead for the strategy. I think Singapore's in a great position to lead on regional standards, lead on governance frameworks. This could be through an ASEAN forum, or it could, involve some sort of translation of global standards that are already being developed. I think the possibilities are quite open at this stage. And the other thing that I think is a fantastic opportunity for the national quantum strategy is to see how to uh, capture the sizable regional market that I estimate will be there in the long term for quantum computing as a service and for quantum safe communication solutions. These will be areas that I think will be in high demand in a region where there may not be as much domestic quantum computing capacity necessitating accessing it as a service, and where there will be a strong demand for uh, security for communications networks. So that's where the quantum safe part comes in. And now, the last part of my presentation, a quick look ahead. We've got the next edition of the Research, Innovation, and Enterprise Plan covering the next 5 years. That's due later this year. My guess is that there's going to be some potential adjustments to the national quantum strategy, even if the document itself doesn't get updated. And here it's really going to be about what are the funding priorities that are being set. Now, with that said, I think you're probably going to see a refresh to the national quantum strategy, maybe in a few years' time. But what that means is the National Quantum Office, CQT, they'll have to work hand in hand to keep tracking what's changing, uh, not only in the technology space, but also how other countries are, uh, you know, putting out their new approaches, how they're changing current approaches, and that needs to then inform a strategy refresh a couple of years down the road. Now, one of the things that I mentioned earlier, which I think is going to be a big factor there, is that you're probably going to have a lot more quantum startups. And it might mean that in a refreshed national quantum strategy, you've got to give more weight to how to advance the industry ecosystem and also the associated value and supply chains. And I'll stop there. If you missed the QR code for the piece, it's up here. Thank you so much.
Thank you, Mr. Harjani, for that informative presentation. Singapore is one of those countries that are the Philippines would like to emulate in terms of the implementation of emerging technologies. And I'd like to see if our participants here have some questions for you, Mr. Harjani. Any question from the audience? Yeah. I but I see currently none. But Mr. Rajani, I'm curious to know how is Singapore convincing young engineers to pick quantum over, for example, fintech or AI? And how is that working? How do you really convince those you mentioned PhD or master's degree holder to choose quantum over other emerging technologies?
Thanks so much. That's a really good question. I don't think there's any sort of overt, pick quantum over the rest kind of narrative in the Singapore ecosystem. There are so many competing sectors with a big shortage of talent. So I think Singapore tends to stay away from trying to, get the sectors to compete with each other. It's already a very difficult environment in terms of attracting in talent. But I would say that there's been, an effort to roll out more access to masters and PhD programs in the Singapore universities. And this is not only benefiting Singaporean students, but also regional and students from basically anywhere in the world. So I think the push for talent from the Singapore perspective is always global in nature. We're just too small a country to focus on our domestic population.
Yeah, thank you. Also, I'd like to ask, I think some of the participants would be interested to know, like, could the Philippine researchers plug into some of your test beds in Singapore or training programs? And how would you advise us to on that route?
Okay, so I can't speak for government policy, but what I can see, at least from where I stand, is that a lot of the initiatives right now are kind of geared towards building up domestic capacity, working with domestic industry players. That doesn't mean, though, that at a later stage it will preclude regional cooperation, inviting the participation of other countries. And I've kind of been a very steady advocate for building out the ASEAN level ecosystem. I think that it's just because you've got 10 countries with different levels of development, it doesn't mean that you don't start to think about some of these longer term challenges and adoption of some of the more exciting emerging technologies. So I think that's where there's a lot of opportunity down the road. But at least for now, I think a lot of the initiatives under the National Quantum Strategy are geared towards strengthening the domestic ecosystem. There is definitely a big part of the work that NQO does, which involves international engagement. And I'm sure there will be plenty of opportunities down the road for not just regional countries, but sort of any country to work with Singapore to plug into what they're doing. And you do see some of these agreements and MOUs being signed. So I expect that there'll be more of that going down the road.
Thank you. Yeah, we're gonna be on the lookout for that. Let's give Mr. Harjani a round of applause. Thank
Thank
you
you so
again
much for having me.
for your presentation.
Thank you so much.
Okay, now from Singapore, we now go to Indonesia. We're blessed to have Mr. Muhammad Hamza Fauzi online.